Hi, Fatih.
Hi, Oliver. Welcome back.
Yes, somehow
Like 3 months or?
No, I was there in between, but somehow the meeting request slipped out of my calendar. Not sure. And
oh yeah, the meeting invite expired just before this summertime thingy, daylight saving time thing, and the original invite I sent it to SIG Interoperability mail list, but the new invite, Kara set the invite. I think she has forgotten to send it to the mail list, which I can do. So you get the invites on your calendar.
Yeah, I created now
Yeah.
and then one was skipped, right? I think the one right before the daylight saving time I participated as well.
Oh yeah, possible.
But
like this, my life turned upside down lately. So
and summer was crazy on my end. Therefore, I tried to be there now more regularly again.
That's good. So have you had a chance to look at the roadmap? I think, we started refreshing it. So we will talk about it anyways when we start the meeting, but just
not yet, but it's on my list.
That's kind of like the supply chain is a candidate to be included in the roadmap as a top level item.
Yeah,
because we have been talking about these things like policy, standardized metadata, but after what's been happening with this White House directives and all those things, we decided to make a top level item, and that's why we started these like in total 6 store presentations and so on.
Yeah, software supply chain makes a ton of sense.
Yeah, that Dan is supposed to be here. I don't know. Let me ping him. And again, we have low attendance than usual. Yeah, we should definitely send the invite to mail list.
Hello.
Hi, Dan. Thanks for joining. Maybe we can give a minute or two. We made a lot of noise about these, presentations, but maybe we should be doing more noise. Let me share my screen. You can see the HackMD, I hope. Do you see it?
Yes,
I can see it, yeah.
Cool. So we can at least start with agenda, I think, and then look at the white paper. Yeah, let me add a topic right now. White paper. Which we need to get an update from Tracy. So the agenda is, as usual, action item review. And then we will quickly take a look at the roadmap. Then we can have a chat on the white paper we finished beginning of this year, I think. And then we leave the stage to them and then learn about SIG Store. So the action items, the first action item is on Kara and me. And that's about the roadmap, which we will talk about it. Maybe we can close the action item and then take the topic again after we have some updates on the roadmap, which may result in additional action items. And the other action item is on Kara to present the work we are doing in here to end user console, which I keep it open. Kara is off this week, so she won't be able to join. So I keep the action item open. And that's all action items we had. Now the roadmap. So to recap what we discussed during previous meeting and as written on the agenda, the roadmap, I think we released the first version around summer 2020, if I am not mistaken. Yeah, I think that's when we released it. It's now almost 1.5 years, and we have done a lot of work, especially in events area, which has become its own SIG, and now the creation of CD events was also approved. So that is one contribution we made to CDF and broader CI/CD domain that requires us to, you know, perhaps drop that from our roadmap and then, you know, include new items in our roadmap, given that lots of things changed since summer 2020, with the most significant one being the increased attention on supply chain security, which is one of the reasons why we have Dan with us today. So in addition to that, I think during one of the past meetings, Ramin mentioned that the policy-driven CD is something he is interested to see, and we got similar feedback from others when it comes to how policy-driven CD could help organizations to employ guardrails in their pipeline. So that is another item we intend to include in the roadmap. Yeah, policy-driven CD. So those are the two potential new entrants to our roadmap while we move events to, you know, as something we accomplished in our SIG, and it is now living its life in CD events and SIG events. And then the other things in the roadmap was like information knowledge sharing, which we have been doing in regular manner. So I think that is something we can consider as accomplished, and we will continue having those type of presentations from different communities to keep on sharing the latest developments from all these different communities. The work stream setup, I think that worked pretty well from events perspective. So we have the governance in place for work streams as well. We can conclude that item as well with links to the governance and examples based on events. The shared terminology, we did some work with that, with our document in our repo, and also events SIG also looking into glossary terminology as well as best practices. We can perhaps include that in our roadmap as current item to see how these things could converge, like best practices, interoperability, and events. And perhaps we can mark it as done and route it to best practices SIG, because that is what they are driving from broader perspective. And the visualization topic is there, and this is kind of a common concern for events SIG as well, because you can use events to visualize your pipelines and reach traceability. So that is, again, we can discuss on the roadmap directly. And then pipeline standardization languages is something we haven't looked at yet, but there were few people who want to, you know, have some kind of standardization when it comes to doing some kind of pipeline as code and so on. We can continue discussing on the roadmap as well. And the last focus area was integration with tools that are not traditionally seen as CI/CD tools. Again, this is a common interest between interoperability SIG and event SIG. I believe event SIG has ideas on this because the events will not be specific to CI/CD orchestration tools, but they could be, employed by other tools that may not be seen as traditional CI/CD tools. Again, we can keep this as an item in our roadmap to look at further. So, any comments about roadmap? I take that as no. Let me put the link to chat. One thing, perhaps then it would be cool to get your opinion about is like it's related with interoperability between the CI/CD pipelines, orchestrators, and security vulnerability tools, or the tools that are active in security or supply chain domain. So the interaction between those tools and pipelines could be something we can take as a discussion point when after your presentation, perhaps. So we can highlight that under supply chain topic in the roadmap.
Sure. Yeah. Lots of great opportunities there.
Yeah, especially with OpenSSF, seeing that all these credible communities are joining OpenSSF, that gives us opportunity to, increase our collaboration from CI/CD to those communities.
Yeah, there's a lot of stuff with the new SBOM formats for software bill of materials and other types of attestations about environments and that kind of thing. So a lot of formats that are important to pipeline execution.
Yeah, I've seen SPDX referred in event SIG meeting minutes like 2 weeks ago or something. So it's like, again, we are seeing like there will be like we will be converging on these topics anyways, but yeah, how to communicate these things with those communities so we can find opportunities to collaborate. But let's take that after your presentation then. And that was the roadmap, and you have the link in the chat. So any ideas you have there, anything that doesn't make sense or anything that we have missed highlighting in the roadmap, please just add them or comment them directly on the document. So that was the roadmap. And the interoperability white paper, I think the white paper is in kind of a bit weird state right now because we talked about events in the white paper, and now events has its own SIG, and we have a project which we all are pretty excited about it. So now that development puts the white paper in a weird situation. Maybe we should look at the white paper again and refresh it, or maybe event SIG has an idea to come up with its own white paper. So that is something we need to take into account. And the other thing in the white paper, we talked about metadata stuff as well, and perhaps policy, but now those topics they fall under this broader supply chain topic. Again, that would be something we may need to rethink about, like how we can associate interoperability versus supply chain. So I think we missed, I don't know if I should say missed the opportunity, but we got delayed with the white paper, and it kind of made the white paper a bit stale. I don't know if it is the right word, but yeah, we definitely need to look at the latest version to see what we need to do there. The end user case studies are still relevant, I think, but the overall structure of the white paper may benefit from reworking on it. Any comments about the white paper?
Just to refresh my memory, what was the, as far as I remember, the last state was that we delivered it over to the creator team and they were supposed to do something and then nothing happened, or was there something else that we should have done? I
think Tracy Miranda presented something that came out from the creator team. It wasn't like the full paper, but some kind of landing page or something like that. And then she also raised some concerns about the structure of white paper, because like, again, we are not marketing people, we looked at things perhaps from technology perspective or technical perspective. So that conversion from our world to, the world of decision makers or the people who may be reading white paper was pending. I think it was like before summer or something like that. So that is the state the white paper was in. But let me take an action item on me and check with Tracy if anything that we need to do there to make it better for creative team to make the white paper presentable for different audiences. I think it's about the question of having different audiences, because it will not be just the CI/CD communities or developers, but we hope this paper will be read by decision makers, managers, or such audiences. I don't know if I answered your
so
question.
It's clear. Yeah, it's just so it's clear of what if it was something more from us need to do, because that was not clear for me at least.
I think we were kind of done, but this, reorganizing the white paper was something Tracy highlighted last time we talked about this topic. But yeah, I took an action and I will check this with Tracy. Again, yeah, we need to reorganize the white paper anyways now with the, CD events and supply chain aspects. So yeah, that work still is pending to be done, I say. Okay, that was it. So I don't want to take on more time, and then if you are ready, I can stop sharing and then leave the stage to you.
Sure, I'll screen share over here. I don't have a super formal begin to end presentation. I've got a couple of slide decks from before and some demos and stuff, and we can kind of hop around between them and answer questions as we go. So the overall goal is to talk about the SIG Store project. So let me find how to screen share that. All right, let's just do the entire desktop. Cool. Can everybody see my screen?
Yep.
Yes.
Awesome. We should be good now. Cool. Yeah. So again, feel free to interrupt at any time while I'm going through here and just speak up because I can't see the hands raised or anything like that. Yeah, I've got a couple slide decks here. We can do some demos, like I said, and some documentation on the websites and that kind of thing to jump around between. But first, I'll start out with just kind of a high-level overview of the overall SIG Store project. So it is here at sigstore.dev. You can see the website. This is a pretty good overview on the scope of the project, what it's trying to do, and how it works, and who's involved, and all of that fun stuff. The easiest way to describe it, I think, is probably what I like is the goal of SIG Store is to basically try to be the Let's Encrypt of code signing. If you think back to what the internet was like, 6, 7, 8 years ago, before Let's Encrypt really got adoption, most websites weren't using TLS and certificates. That little red X, the scary X saying something wasn't over HTTPS, it was only over HTTP, it was pretty common, way more common than it should have been, right? There were even banks and financial institutions and places sending passwords unencrypted over HTTP. And this is true even though certificates and browsers had been around for 20 plus years, dating back to the early 90s. They just weren't really that adopted because it was hard to use them. It was hard to get them, right? You had to go find a certificate authority. You had to pick one out of the dozens. You had to pay them some money with a credit card. Some of them were kind of sketchy. They'd send you back a certificate, these files over email. You'd have to craft something from the command line first to send to them as a request. They'd send you back as like an attachment. You'd take that, drop it into your Apache folder, hopefully get it in the right place, and then maybe your website would actually serve correctly. And then you had to remember to do it again in a year because they'd expire. If you forgot, the certificate wouldn't be trusted anymore, and it was a big mess. looked around at the kind of open source software supply chain ecosystem and landscape, sometime in 2020, I think is when this effort basically kicked off, and kind of did a survey and found that a lot of the same problems existed here. There were ways to sign code, but nobody was doing it. There was the PGP kind of web of trust ecosystem that never got critical mass and relied on people preserving their keys and sharing them at parties. And then there's kind of the parallel ecosystem set up around kind of code signing certificates, which are exactly like web browser certificates. You'd buy them, have to do some kind of identity check to prove who you are. If you weren't a real business, it was really hard to get them. They were like $500 and they're only good for a couple of years. You had to make sure not to lose them. So nobody was really doing it unless you had to, because you were trying to ship software in like the Windows drivers or one of the app stores that required certificates. And so we said, well, what if we kind of do the same thing Let's Encrypt did and set up an automated API for getting certificates? We'll make them super short-lived, so you don't have to worry about renewing them. You just get a new one each time. And then try to build tooling to automate all of it. And so at a high level, that's basically what SIG Store is. All the different components are set up just to make it easy to get certificates and publish them and discover them for your code. So you don't need to buy anything. It's completely free. It's community run. It is a kind of separate project as part of the Linux Foundation. The infrastructure is managed by the community. The certificate authority is managed by the community. And so it's all free for open source and everything. The complicated technology powering it is a whole bunch of transparency logs and timestamps and cryptographic proofs and everything. But as an end user, you don't really have to worry about that. You can just sign code with a simple command without having to worry about keys. You can verify your code with another command without having to worry about how to find keys for people, and trust that everything is being run correctly because it's all using transparency logs and transparent infrastructure. So people can monitor and audit this to make sure nothing bad is happening. These are the different components kind of listed out down here. I could do some demos, but we started with automation with the cosign command, which allows you to sign and verify container images that are part of the OCI or Open Container Initiative specification. So this works with any kind of container image that is stored in an OCI registry. You just do cosign sign and stuff gets signed and pushed inside of registries. So this works on stuff like Docker Hub and GCR, Google, and the Azure Container Registry, and anybody that implements the OCI specification. One of the other cool benefits of using the OCI spec is that you can use that for things other than container images too, which is great for an interoperability perspective. You can store any type of artifact in OCI registries now, and so people use it for distributing other types of binaries. One big example there is Homebrew. Really, with Homebrew, it's the package manager for Mac. They switched to using the GitHub Container Registry for hosting and distribution of all of those binaries, even though they're not container images. Stuff like WASM uses this specification as well now to avoid having to reinvent a new package manager for a new ecosystem. So it's set up for containers, but it really works with anything stored in one of these registries, which is starting to expand beyond containers because of the kind of vendor neutral specifications that are present. This works though using these other components on the right, Recore and Fulcio. So Recore is the name for the transparency and timestamping service that we use. This is the transparency log that stores all of the records for signatures and artifacts and that kind of thing. If you're not too familiar with transparency log, they're very kind of subtle and there's a lot of moving parts there, but you can kind of think of them as an append-only log that can be verified to be append-only. So if one person is running a transparency log, you can add entries to that log and you can make sure that they haven't tampered with any of the previous entries or deleted any of the previous entries. So you only really have to trust the operator to keep the log running. You don't have to trust them to maintain the data correctly because you can verify it. This is the basic infrastructure that powers certificate transparency. So very similar to Let's Encrypt again. Anytime a certificate authority issues a certificate, they have to get that certificate into a transparency log where anybody can look and find it and see that they issued that certificate. This is critical to web security because it prevents somebody from accidentally or maliciously issuing a certificate for a domain that they shouldn't have. You can imagine how bad it would be if a small CA issued a certificate for google.com or microsoft.com or something like that. They could man in the middle or hijack all of that traffic. So the transparency logs are what keep these certificate authorities honest. And that works here too. It keeps code publishers and even the SIG Store community honest. Then the final one here, Fulcio. This is the certificate authority itself. This is what actually issues code signing certificates to people and systems and machines and CI/CD pipelines and all that. So going back to the Let's Encrypt analogy, the first time you get a certificate for a domain with Let's Encrypt, they do a series of challenges to prove that you actually own that domain. That's what kind of provides the security guarantees before they give you a certificate for your website. They make sure that you actually own the domain, and so you're authorized to get certificates for that. With Let's Encrypt, they had to kind of invent some new standards because nothing existed here. And those standards are referred to as ACME. I forget what it stands for, but those are real IETF adopted standards for these challenges. They look something roughly like calling the Let's Encrypt API. They give you a random token, and you have to put that token somewhere in the DNS record for the domain or in an HTTP header or something like that. Something that only the operator and owner of that domain should be able to do. And then they query the DNS records until they see that challenge, and then you're issued a certificate. Well, it turns out that with developers and people, there's actually an already great set of APIs to do those challenges, so we didn't need to invent anything new. It's basically referred to as OpenID Connect or OIDC. And that's what happens when you want to authenticate with Google or authenticate with GitHub or one of these identity providers on a different site. If you ever click the login with Google or login with GitHub button, that's what's happening here. Your browser pops open to that site, you click OK, and then the two services share proof that you are that actual person. So based on that standard, Fulcio kind of pops open your browser, you click login with Google, and then you get a certificate issued to your own email address, which is the form of identity that we use here. So all this stuff put together makes a kind of super easy and frictionless flow for signing and verifying code and metadata. Any questions here before I go over to some kind of demos of the presentation itself?
Quick question. So you said
Sure.
It was free for open source projects to use, but is it itself open source? Is it developed by an open community? How do people get involved in helping improve it? Can you run your own copy of it for testing or to bootstrap your own separate community of code signing, et cetera?
Yeah, great questions. And I was probably a little imprecise there. Yeah, so this is all open source. It's all here at github.com/sigstore. A lot of stars, a lot of community adoption, all of that fun stuff. The different components are in here. There's some other Valve repos and stuff like that. So this is all free to use, and the community run infrastructure. So this is why it's a little subtle. So all the code is free, right? All the code is open source under permissive licenses. The community infrastructure that's operated is also free to use, right? That consists of this hosted certificate authority, all of the APIs that we run at under sigstore.dev. So that's the transparency log, the certificate authority, and some other little services. That's also free to use and run by the community and some corporations that sponsored the infrastructure. The kind of subtle part though, it's technically free for anybody to use, but everything is public. So you can sign and throw stuff on here that's like you can sign closed source code, but you have to accept that it's going to be public on this record. Sometimes that's okay, right? If you're distributing a binary that's built from closed source, you might still want to sign that binary and put that on the public record. But if it's like internal stuff that you never distribute outside of your company, then it might not be appropriate, and you might not want to leak, the different builds you're doing on this public record. So you can run these components internally as well. Some of it isn't completely relevant, but yeah, it's kind of mix and match. The transparency log itself in particular doesn't always make sense to run internally. The way transparency logs work is they kind of can issue challenges to prove that things haven't been tampered with, and you only really get the tamper-proof guarantee if you have like a third party or somebody else actually auditing the log. And so if you're running this internally, then sure, it probably won't be tampered with, but unless you have somebody kind of in a separate trust domain verifying it, you're not actually kind of taking advantage of those guarantees. But yeah, some of the other components still make sense to run internally, like the certificate authority and the different signing tools and everything. So yeah, the open source community infrastructure is free for anyone if you're willing to accept the kind of public nature of it. Does that answer that question?
Yep, perfectly. Thank you.
Yeah. Cool. Yeah, there's definitely some subtlety involved in there. One of the other interesting points of the community infrastructure I'll get into here quick before I jump into the presentation, because I don't think this is covered too well, is actually the cryptographic root of trust that we maintain here for the community. So the short-lived certificates and everything like that are cool because you don't have to manage keys, but that still doesn't really solve the entire problem, right? This all just chains back up to a different root of trust. With browsers, this is managed by like the kind of browser forum has a root CA kind of program where they publish requirements on how people have to operate their certificate authorities. And if you do that correctly, then you can get your certs trusted by browsers, which is how it works on the internet. That doesn't really exist. So we kind of had to bootstrap something here too for open source signing. And so we maintain this kind of community cryptographic trust root again, in the community and in the open. So this is the repository that contains all of the keys that sign everything else in the SIG store trust root. So there are 5 community members that actually hold physical hardware tokens. These are the YubiKeys or something similar. And we need a kind of quorum of those 5 to actually make any changes to the cryptographic trust root here. So this is set up using the update framework, or TUF, which is another open source project under the Linux Foundation. It provides protections for rotating the keys, moving people in and out, expiration, and all of that stuff. So the initial one was bootstrapped in a live streamed YouTube ceremony, it's called, which you can watch, where people from the community watched and verified each step of the way, and it was all done kind of in a pull request flow, where we all kind of took the keys out of the packages, held them up to the cameras, that stuff to show that they weren't tampered with, published the public keys, did some signatures, and got all of that stuff here checked into this repository. So this repository is the actual trust root for everything else, and it's been forked and cloned all over the place, so it can't be tampered with. And then every couple months we have to get back together and re-sign something before it expires here, and so everything else kind of chains back up to this. This is pretty cool. A lot of companies do something similar internally with KMS systems or hardware-backed tokens, and cloud providers even offer a lot of those as services. But that stuff doesn't really work in a distributed environment where you don't really trust the other people. So it was a pretty fun, we had probably a couple hundred people watching live when we did the first ceremony. Cool. Any questions on that before I jump back over to here? Actually, here's a good slide showing the kind of open source stats that I was just talking about. And this is a little outdated, a couple of months old.
Yes, one quick, maybe too deep question.
Go for it.
the multi-part keys. So the solution there is using something like Shamir secret key sharing or some other mechanism?
Yeah, it's slightly different. It's conceptually similar where you need multiple keys to do something, but it's actually managed explicitly and kind of above the crypto layer. So Shamir does that kind of at the crypto and algorithm layer. This is just kind of like the update framework setup. Let me see if I can find the right file in here. I just forget how these are set up. Yeah, okay, so it's really just a simple kind of JSON file that lists the actual keys and then the policy requiring how many of them have to be used to sign and make a change. And then all of those keys kind of sign the initial one, so you get a self-signed root. So it's not anything super fancy crypto like Shamir. It just says, here are the 5 keys in the root. And then there's a threshold in here somewhere. So this says when it expires, we have to sign a new one before this date. This was the original one, so we've actually signed a couple since then. And then there's roles and delegations. So you can say subkeys can sign certain things, and then here's the threshold. So unless you have 3 out of the 5, you can't make any changes to these things. If that makes sense. So the nice part, you can do this with any kind of algorithm selection, like Shamir's. I don't think you can quite do it with anything. There's like RSA, CDSA, EED 25519, all of that fun stuff. And it's also a little bit more explicit. So like with Shamir's, if you wanted to set it up with like 3 out of 5, then I think you can't actually see which 3 did it and stuff like that, which is nice in some cases. But here it's a little bit more explicit. So you can see which keys signed it, which keys haven't, who you're still waiting on, and that kind of thing.
Cool.
Be a good question.
Yep. So like the threshold cryptography that Mesh is using.
Which Mesh? Sorry, I'm not familiar with that.
So It's still in development, but
Okay, cool.
never mind.
Yeah. Awesome. Yeah. So if you look this up, if you want to get into more details about how this works out, it's part of the update framework, and there's a whole specification and all the different things that are addressed here with the roles and the timestamps and all that fun stuff. There's a whole world of supply chain attacks and with package managers and update systems that the update framework addresses that you might not have ever even considered. It goes very deep. Cool. Yeah. So here are basically stats, 100+ contributors, a whole bunch of companies involved, lots of GitHub stars, that fun stuff. I think we're actually getting close to 1 million log entries now. This is a little old. And there's work going on now to actually make it so we can shard that log and migrate it if we ever have to, and fun stuff that way. So if you want to get involved, yeah, there's a lot of projects. There's developer tooling integrations for signing. There's infrastructure you can help run, release engineering, a lot of fun ways to get involved and help out. Let's see what I'll talk about next. I guess I could try doing some demos quick, showing how this works with containers. Would that be interesting?
Yes.
Awesome. So let's go into the cosign directory. I'll clean up. Might have two. Cool. I'm just going to delete all the signatures, get my image all cleaned up. People see my terminal, or should I make it bigger?
I think it looks good, at least to me.
Okay, cool. So this is just, let's see, do I have anything going on here? Yeah. Cool. Yeah, do a build. So this is cosign. It's the easiest way to get started. This is all Go. So there's a bunch of different commands and things in here. Where am I? All right, this should be the right repo now. Yeah, so this is all hosted on GitHub. There's a couple different binaries in here, actually, including like some Kubernetes integrations and that kind of thing. But the cosign command line tool itself is easiest. So we can do cosign and see all the different subcommands. There's a lot of stuff going on here. Even some work with stuff like SBOMs and other types of attestations. The easiest flow here is actually to use normal keys instead of the fun keyless certificate authority flow. So I'll show that and then show how it works if you want to not manage keys too. So the first way, we get started with generating a key pair. And this actually supports a bunch of different cloud KMS systems if you want to use that, like GCP, HashiCorp Vault, Azure, AWS, all that stuff if you want to use the cloud-based ones, or you can just leave all of that off and just do generate key pair. So this is going to generate one on disk. So I'll type in your passphrase so it can get encrypted. Overwrite the old one. Cool. And now we get a key pair, a cosign.key and a cosign.pub. This uses basic ECDSA stuff, which is FIPS compliant and meets all of that, the government regulations and fun stuff. I'll show you what it looks like here. I'll start with the public key. This is a standard PKIX or X509 public key using the ECDSA algorithm. So this is the thing you want to share if you want people to be able to verify your signatures. You want to distribute this as widely as possible. I'll show the secret key too. This is the thing you normally don't want to show people, but it's encrypted actually, so nobody can do anything with this unless they also have my passphrase, which I didn't show. So it's safe if you accidentally check one of these into Git and publish it. There's actually some cool flows you can do by checking them in on purpose, which I'll show. I can show an example of that one. But yeah, so here is the public and private key pair. So now we are going to sign an image and verify it. Let's do. Okay, so let me drop experimental. That's for the cool features. This isn't signed right now, right? So this should fail if I try it. So I'm going to pass in the public key I want to verify against because I cleaned this up at the start. I deleted, and awesome, it fails correctly. No matching signatures. So now let's switch this and we'll sign it. We pass in the private key this time to sign it with. Should ask us for our password. And now it's signed. This is using GCR, but you can do this with GitHub, any registry that you're kind of authenticated against. So now if we want to verify this time, it should work. Yay. So this says all the checks it did. We didn't use certificates or anything like that, so those checks aren't really relevant here. But we verified the signature itself. Let me do this again, but pipe it to JQ so you can see what we actually signed and verified. So I signed a container image here by its tag, right? If you just do gcr.io/for-testing/distros or whatever, that implicitly adds a tag of :latest, and that tag can move around. So we're signing something like a pointer in this case. So what actually happens is that Cosign resolves that tag to the digest. The digest is the SHA-256 identifier for that image that cannot change. So instead of signing something that can change and move around, we sign the digest itself right here. That is what it pointed to at the time that we did the signature. So if we were to move that tag or push a new image or something like that, that would invalidate the signature correctly. That's a good thing. So that's kind of what that signature looks like. Pretty basic. You can just express whether it's signed or not. You can sign something multiple times with different keys, with the same key, and kind of mix and match and do verifications. That way you can require like 2 people to sign something. You can require 2 out of 5. You can build up that threshold stuff. Or you can say any one of these 3 keys if you want to support some basic rotation. There's one other little feature I'll show here quick. We support these little custom annotations. So if you want to say, you build up, which you can use these annotations to build up more complex workflows if you want to. So here I'm going to add one saying foo equals bar. Now, if we sign or if we verify, we'll see 2 signatures. The first one, which had no annotation. This is the first one from before. We've added a second one now that does have this kind of set of annotations. And I didn't specify anything for verification, so I got it all. But you can pass those same flags in for verification now. And now we should only see the second one. Yeah, awesome. So you can use this to put stuff like commit information or timestamps or release version numbers and that kind of thing to build up more workflows if you want to. Say that this has been approved and this still approved, or this passed the security scan or something like that. You can stick that in here in the annotation section. And yeah, well, I was also going to show the keyless modes now. So this is cool, but it requires you to kind of distribute that public key. Here's one example of how to do that before I jump over to the keyless stuff. I have one here. Yeah, this is a little example showing how to do all of this stuff inside of GitHub Actions to do signing and verification. In this one, I actually committed the private key. And again, it's encrypted and the secret is stored in GitHub Actions as a secret. But what this allows you to actually do is by committing the public key and the private key is you can easily rotate, right? In the GitHub action here, what we actually do is stick the commit hash that the container was built in that annotation field. And so if you ever want to change these keys at any point, you can just kind of blow them away, add new ones to the repo and a new commit, and push that commit. And because we sign the commit itself, you kind of get this self circle of the commit telling you which key to verify against. So you can go to the repo, you can see which commit the thing was built at, and you can look up the right key to verify it against just with this kind of in-band rotation mechanism. But if you don't want to worry about rotation at all, you don't want to worry about key management at all, that's where the rest of the SIG store stuff comes in. So I'll show some of that. So that is the experimental stuff. Let me clean this up again just to get rid of those old signatures. Cool. Now we're going to turn on the experimental mode. And do a sign this time, but with no key. So before we had to pass the key, this time we're not going to do that. Because experimental mode is turned on, this is going to work with the fun keyless flow. So with no keys at all, this is the OpenID Connect prompt that I talked about. So this pops up. I'm going to log in with Google. And cool, that's it, we're done. If you look here at what happened in the terminal, so generating ephemeral keys, retrieving signed certificate, and your browser will now open too. So This generates the same type of keys we did before, but it does it all in memory. So those keys never touch disk, they can't be leaked, and they're kind of bound in the certificate to a very short time window. I think it's like 15 or 20 minutes. So these keys can only be used within 15 or 20 minutes from the time they're first created, and they're never really written anywhere outside of here. Then we take that key, put it in a certificate request, send it up to Fulcio, which does this challenge to make sure that we actually own the correct email address. It gives us the certificate, we sign the image with it, and then all that stuff gets thrown away and put into the transparency log. That's what this section here is. So if we want to verify again, let's see what this looks like, and then I'll show what the transparency log stuff actually looks like under the covers too. So I'm going to verify, get with experimental, turn on no keys, and go through JQ for good formatting. Awesome. So a lot more info this time, and that's because of the whole certificate setup. So I'll break this down. This is the same stuff as before. Sign the image, here's the digest, but now we have a bunch of other information in here regarding the transparency log and the certificate and that kind of information. This tells us the entry in the log, which we can use to look stuff up later if we want to. This also tells us that this, what email address I verified this against, right? So this is my personal Gmail account. And this is what it was verified against, right? Because Google actually did the vouching and verification here. Google said that at that time, I controlled the Gmail account. So this is all thrown here into the signed payload that you can check against. Multiple people can sign it with different email addresses. You kind of tack all these on. One of the important things to note is that kind of SIG gives you all these primitives to sign and verify things against your identity, which is an email address, but it kind of stops just short of telling you who to trust, right? We give you the tools to write these policies and decide who you trust, but just because something is signed doesn't make it safe. It just means that the person with that email address signed it. If you don't trust that person, then it doesn't really add much. You have to kind of build that stuff up on your own, but at least you can prove that that person signed it and nobody else tampered with it along the way, if that makes any sense. Let's look at the transparency log now for this. So there's a separate CLI. Cosign does all this automatically under the covers, but if you want to play with the transparency log directly, there's a separate CLI called Recore CLI for the transparency log. So I'll do log info here. You can see, yep, this is the size of the tree at this point, getting close to 1 million. This is the hash. Every time you run this command, if the number goes up, we actually do a verification here to make sure the tree hasn't been tampered with. So we can see the last time I ran this actually, I ran the log info at 86516. Now I just ran it again at 906961, and we did a little verification to prove that nothing had been tampered with in between those, and that the log is just append only. So you can see that here. So we store the new size locally, and every time you run this, you're kind of verifying and making sure that the tree is good. Let's grab that entry from before. What was it? Cool. You can get stuff by the index or by the digest of the entry. Either way works. No, I think I have a broken build here. I was doing some development this morning. See if I can quickly fix it. Otherwise, I'll move on. Yeah, so this will pull down the exact entry that I uploaded, which has the digest, it has the key, it has the certificate, and all of that information. If I can fix my CLI quickly. Yeah, this is kind of what Cosign does under the covers for you. No, broken demos make me sad. There we go. Awesome. Fixed it. And let's do some formatting here. Format equals JSON. Yeah, there we go. Awesome. So this is everything that's stored in the transparency log for this entry. We can see the digest of the thing that we signed. We could see the signature itself, and we could see the public key that was generated. So if we take this part, so it's body hashed signature. And we'll actually look at this certificate. Get this working. this should look like a certificate. Cool. And then we can pipe that into OpenSSL. Maybe that. Cool. So this actually displays the full certificate. So we can see what that looks like that was issued by SIG Store. So here's the ECDSA P256 stuff for the algorithm itself. We've got the issuer SIG Store. You can see that this is for code signing. If you compare this to a certificate from Let's Encrypt, that would say something like, I forget the TLS, whatever the key usage is for that is. And then we should see, yeah, here it is. So this is the subject. If you get one for a web browser or a domain or something like that, the subject would be for the domain. But this, because the certificate is bound to my email address, we use the email field in here. Then it is the signature on the certificate itself that we verify against when we want to check stuff. So this is what the certificates for the key stuff look like. These get stored right in the signature in the container image as well as in the transparency log. So the cool property of the transparency log, again, is that you can audit that log. You can go through each entry one by one or set up a little system to do it for you and look for things issued with your email address. So just like most companies do if they're using certificates, you can run a little bot to check to make sure that nobody's issued a certificate for your domain that you don't understand. So your t.sh is one little site for that. So you can type in something like google.com and then see all of the certificates in the transparency log issued for Google. You could do a similar thing with the Recore transparency log for your email address. There's a little command to search it and it'll tell you all of those. So if you see something you don't expect, that means somebody probably compromised your credentials. And you can remediate or take action from that. Yeah, so there's a bunch of different modes in this. You can search stuff, you can get timestamps signed, you can create other entries. The flow I showed just uses basic signatures and cosign, but you can do stuff like, there's a bunch of other different signature formats. So if you're still using PGP or something, you can store that in Recore. There's new SSH certificates where you can sign things with your SSH public keys, and Git just added support for that. So you can actually sign Git commits now with SSH public keys. You can store those in the transparency log. Pretty much any signature format can get uploaded and stored in here. Let's see if we got a new entry yet since. Cool, yeah, there are a couple more entries added while I was doing those demos. So I did another proof here. Awesome. I think that's about it for the demos I have. Any questions on this stuff?
I have a question about community adoption. Like you mentioned, like you have almost 1 million entries, like 900,000 something. Like I also see lots of, tweets on Twitter, like Kubernetes is doing this, the other community doing that. Like, how is the adoption going? Like, will we get something like Let's Encrypt, like SIG Store for the masses kind of thing? Like,
I hope so. Yeah, a lot of it is about automation and tooling. And so it's something that we're pretty excited about. Actually, there's a blog post on my company website I'll pull up just yesterday, just to make this even easier. Something one of my colleagues wrote to help a lot with adoption is I showed the kind of interactive person flow where it pops open your browser to verify. The cool thing though is OpenID Connect is also used for systems and service to service integration. And this is particularly relevant for I guess this group and the CDF in general, but you can do OpenID Connect with service accounts or machines. And one of the really exciting recent changes is that we work with GitHub to get GitHub Actions to support issuing OpenID Connect tokens to the workload running inside of the action. And so if you run cosign sign from inside of GitHub Actions now, this little demo shows you how. All you do is cosign sign, no keys or anything like that inside of GitHub. Then it works. GitHub gives you a token, which you can send up and get a certificate issued for. And so stuff like this, I think, is really key to adoption because it means you can just kind of in one line start signing all of the builds from your CI system because it's built on kind of these interoperable standards that already exist. So if we scroll down, you can see what that looks like. And it's actually pretty cool. Because instead of just an email address, what GitHub puts in those tokens is the full repository. action that ran itself. So here's the file to the action in the repository, and then what ref it ran at. They even include some extra information that I think we took out of here, but it's shown these dots of the exact build number that ran, the invocation, the commit digest, who triggered it, and all that stuff gets thrown into those tokens. And so just by turning on one flag, no key management or anything like that, you can sign everything coming out of GitHub Actions. Tecton CD supports the same thing depending on which cloud provider you're running it under. Google has something called workload identity. Amazon, their Kubernetes system has something similar, where your workloads running on their virtual machines or inside of containers can get these tokens that are scoped to the exact instance or machine or something like that that's running, and you can get certificates bound to those then. So yeah, the interactive stuff doing it from your personal machine is good, but the adoption there is limited to how many times you build and sign something yourself. Right? That's kind of generally an anti-pattern anyway. So the existence of these new automated systems is what's really driving the more people turning this on. If you're familiar with the Go Releaser project, it's an awesome tool set for building and releasing Go projects from GitHub, GitLab, whichever source code provider you're on. But this will turn a Go project into images and Debian packages and RPMs and all of the different ways you might want to distribute something from code automatically. And this supports now that same kind of stuff. So if you give it a token, it can sign everything for you using all of the SIG store tooling. So yeah, getting everything automated and making it so people don't have to think about it anymore is kind of the next big step.
Yeah, exactly. Because when you start looking at this blind chain stuff, you notice communities start adopting SPDX, for example, and everyone is trying to make things easier for others. Because if it is not, if it is difficult, then it will be very difficult for communities to adapt, because this, having a non-intrusive way of enabling these things, one line in the pipeline code or whatever, would make things a lot easier for communities. Yeah.
Mm-hmm. Awesome. Yeah. Any other questions or anything here? I think we're basically out of time.
Okay. Take that as no. So thanks a lot for this, Dan. Much appreciated. And it's I've seen your demos on Twitter, but seeing them live was even cooler. So thank you very much for joining us today. And we will probably come back with questions or stuff to your way. So with that, I thank all of you for joining today. So our next meeting, and possibly the last meeting for this year, will be in 16th of December. So until we see each other, I hope you have a very nice rest of your day and nice weekend, since it's almost weekend. Yeah, Thursday. So talk to you next time. Thank you for joining.
Thanks. Bye.
Bye.
Thank you. Bye-bye.
Bye.